Hello, my name is Cristina Costa and I am the CNIT delegate for the ETSI MEC Industry Specification Group. Today I am very pleased to present this episode of the MEC Tech series focusing on the MEC native applications. In this episode we will talk about edge native applications and how they can benefit from the MEC APIs. First, we will dive into the concept of edge native application and how they are different from the cloud native ones. Then, we will explore the role of ETSI MEC APIs in creating compelling edge-native services that take advantage both of the vicinity to the user and of the knowledge acquired at the edge. And then we will explore some use cases. Finally, for giving the feeling of how they work in practice, we'll play a little bit with a simulated environment created within the MEC Sandbox. Instead of building a full application, we will use a Jupyter notebook to query the MEC APIs exposed by the MEC platform in the sandbox. Before we proceed, you may want to check the episode 4 of the MEC Tech series for an overview of the MEC Sandbox, and then episode 12 for an overview of the location APIs. At the end of the video, we will point you some additional reference materials from where you can continue learning about ETSI MEC-enabled edge-native apps. But now, let's dive in a little bit on the edge-native concept. What edge-native concept means? First of all, it's a paradigm shift. As the name suggests, edge-native is inspired by the cloud-native concept. When we speak about edge-native, we are referring to applications that are not just running at the edge of a network, but have been designed and built, keeping the characteristic of the edge cloud environment in mind. Design the edge-native application requires specific design requirements, and being cloud-native is not sufficient anymore. Indeed, the edge can offer many interesting capabilities for running applications, such as low latency, enhanced security, resilience, network awareness. This translates to a better QoS, a better data management, greater resilience, improved user experience, and enables also new use cases and services. These benefits come, of course, with some constraints to the limitation of available resources at the edge, the heterogeneity of the underneath infrastructure, and the mobility and portability requirements. However, edge application can take advantage of the computing and storage facilities located closer to the edge of the applicator's network. Being located at the edge cloud in many ways bring all the capabilities typical of a cloud in terms of virtualization, multi-tenancy, scalability, just to name a few. All these factors have an impact on the apps, but since edge-native applications take them into account at the design phase, they are well equipped to explore all the advantages offered by this environment. ETSI MEC, with its MEC platform placed at the edge of the operator network, enables a large number of new features and gives support to edge-native applications. By accessing to the MEC REST APIs, edge-native applications can find answers to the many questions that a developer can have. Being able to answer to these questions opens the door to build new and unique services. Before getting to know the MEC REST APIs better, let's see some examples from the MEC use cases. Gaming, remote desktops, augmented reality, cognitive assistant are just some examples of services that benefit directly to the end users, the one that uses the user equipment. Edge services can, for example, support use cases that require high bandwidth and low latency content delivery. Here we can see, for example, an augmented reality service. The user needs to receive the augmented reality object in time to be rendered at the user equipment. The edge application has the job to cache the AR object and data needed by the user. In response to a request from the user, the UE is connected to an instance of the edge application that runs on a MEC host able to fulfill the requirements required by the edge application in terms of latency, compute resources, storage, and resources. If this application is not yet running, a new instance of application is started. It can happen also that the UE moves to an area that is not associated with the host on which the application is running. In this case, the instance of application might need to move to another more appropriate host. Another example, we can see here another example. Even traditional services can benefit from the edge. The Run Analytic Edge application in this example is designed to improve the user equipment experience and the QoS by supporting a streaming server with throughput guidance information that is computed based on the radio network information, the NIS data obtained from a MEC service running on the MEC host. Edge services can also be operated in conjunction with third-party services companies. A typical example is the V2X services. In this case, the application can either be running permanently on the MEC host or instantiated on demand, for example, in response to a request of a third party. Once running, the application collects the location-related information from the UE that is connected to the radio nodes, which the MEC host is associated with. The application collects and analyzes the information about the users, which the UEs are present in the area and where they are located, and anonymize them. The result of such analysis can then be provided to an external entity after anonymization. For example, in a V2X scenario, the application can recognize road hazards and dispatch warnings to the nearby cars with extremely low latency in a matter of milliseconds to allow the driver to react timely. Once running, the application collects location-related information from UEs that are connected to the radio nodes, which the MEC host is associated with. The application collects and analyzes the information. Now we are going to explore how the MEC Apps interact with the MEC platform, the MEP. To do this, we will use the simulated environment created by the MEC Sandbox, and we will use a Jupyter notebook to interact with the MEP. A Jupyter notebook is basically a web application in which we can run live code, visualize data, and add explanatory text, all in the same place. It's very convenient since it allows us to follow step by step the live interaction of a map with a MEC application and visualize the intermediate results. So, instead of building a full app, we'll interact with the MEC APIs exposed by the MEC platform using a Jupyter notebook. We'll go through the following steps. First, we'll initialize the MEC Sandbox and the Jupyter notebook. Then we'll start up the MEC application by notifying the map that is up and running. We will then retrieve information about the users in an area using the MEC location APIs. And finally, we'll gracefully terminate the MEC app. Let's start then. We'll now access to the MEC Sandbox to retrieve user information token that we will need for granting the Jupyter Notebook access to a sandbox. Then we'll create a new application instance and get its ID. We'll identify the application instance every time we interact with the map. We will now open the ETSI MEC Sandbox. First of all, we will select a network, for example, the first one. Here is first initializing. Okay, we can add some UEs. Next, we will create an app instance. We'll call it new app, and we'll choose the MEC platform and create. You can see here the ID of a new application that we have just created. We'll copy it and save here. We'll create a variable, and then we will also save our MEC platform ID. Now we can run this piece of code in order to save our changes. Next, we have to create this MEC service-based path. For doing this, we will need the authentication token that will allow us to interact with the ETSI MEC Sandbox. To find this API, we have this token. We have to go to the MEC Sandbox, choose API, application support, and here at the bottom you can see this box with try it now from your user application. Here you can find a service-based path that is composed in this way. Base address, a token that is the authentication token that we are looking for, and then information about the MEC platform, about the MEC API and its version. So let's go on. We can copy the authentication token from the sandbox here and then run to make the changes effective. We need to import some libraries. For example, we will import the Research libraries that allows us to make the calls to the APIs, the JSON and the Pandas API. We will first of all use the MEC application support APIs, the MEC 11. Now we are ready to interact with the map. First, we will notify the map that the application is up and running. Now that the map knows that the application is running, we want to be notified in advance when the application should be terminated in order to gracefully terminate it. And then we will check if a service is subscribed. We will be using the MEC application support API, the MEC 11. First of all, we will set the path for accessing this API. That is the base path that we defined before, plus the name of the API, MEC Apps support, and its version 2. The first thing, we will notify the map that this instance of application is up and running. We will do so by calling the method confirm already. We will compose the URL using the base path that we created before with the applications, instance ID, and confirm already, the name of the method. We will check in the Swagger, and that we can access through the sandbox, the correct format that we should call. You can see here from the application ready that is a post method and it needs a body. We can copy it and we can add it to the payload. We define the method as a post and we can call. The status code is 204. We can check in the Swagger. 204 no content. It means that it has been accepted. Now we will check if there are any subscriptions for the applications. So we will use the method subscriptions, and it's a get, and we will check status code 200. Let's check in the Swagger what this means. Subscriptions. So this is a success. It's empty because there are no subscriptions at the moment. Let's now proceed and subscribe to the app termination notification. That is a notification that the application will receive whenever the MEC decides that the application should terminate, so that the application can gracefully terminate itself. For this, we will use the method subscription, and we will use the post for indicating to the map application which is the callback to be called whenever the application should be terminated. So now let's check again the subscriptions. We can use the same code as before. Let's check it. Okay, first let's run this one. Okay, check. Let's have a look at the output. Okay, we can see that the subscription has been accepted. We'll now use the location services to retrieve information on which users are nearby and their position. Then we will subscribe to the zone location event subscription that will notify me every time a user enters in the zone. We will now interact with the location API. The base path for the location API is again the same base path as before, but now the location APIs are accessed in this way with the location name and its version. And we will be using version number 3 and run. Before proceeding, we will use the service management APIs for checking if this service, the location service, is actually available in the chosen map. So we will use again the MEC base path and then compose our base path for this service. The service management API, and we'll be using the version number 1 in this case. The following method retrieves information about the list of MEC service resources. We will query it to check if the location API is actually available. Let's check the response to see if the location API is actually available. And we can see here the list of PAM and here the location API MEC 13. We'll now check which zones are available using the location APIs. We will use the query zones method to get this information. So let's look into the detail what is available. We have 4 zones with the number of users for each zone, the number of access points, and unserviced all access points. Let's see now how to get information about the location of the user UIs. We can use the query users to get this information. So let's query and see the result. Okay, we can have here the address of the users, the zone ID in which it is, access point, location information, time spent. So you can have a lot of information regarding each using. We can also subscribe to events regarding the location zones. In this case, we get a notification every time there is a change in the zone. Let's see that here the payload is more complex, and we have information about the UIs that we are looking at, the zone ID, the callback to be called, and so on. Let's run this query, and it gives the status code 201. It's okay. If you check the sandbox, we can see that for example, here you already had a callback for the zone number 3.
No. If a MEC decides to terminate the app, it sends a termination message using a callback. The app needs then to gracefully terminate itself and delete all the subscriptions. In our case, the zone location event subscription and the termination subscriptions.
To gracefully terminate the MEC application, we will first delete all the subscriptions. First of all, we will delete the location event subscription. We will first check which subscriptions are active. Okay, see? We can see that we have one subscription that is active. Okay. We will use the output of the previous query to iterate on the list of subscriptions and delete each of them. Okay. Now we are ready to delete also the app termination subscription. But first we need to retrieve the subscription ID. We will do this by querying the application subscriptions. Let's check how many subscriptions is found. I found 3 subscriptions. Let's check which are the subscriptions IDs. So let's add another. We will do it in this way, and we can see we can extract from the list of subscriptions ID. Now we will delete them one by one. We will iterate on the subscriptions list and delete them. And now it's done.
So, to wrap up and conclude this episode, here's what you learned. You have learned about the basic principles of native application. We explored some use cases and used it as Jupyter Notebook to interact with the MEC Sandbox. Interested to learn more? Please explore the step-by-step tutorial on how to develop a full MEC application using the MEC Sandbox HTTP REST APIs. Check also the talks 12, Location Service APIs, and episode 4 on the Sandbox. Then you can also play a little bit, continue playing with the MEC Sandbox, and follow, of course, the next episode of the MEC Tech series.